And now we are going to study the differentiation of inverse trigonometric functions. And in this regard, I am going to prove some important theorems on the differentiation of inverse trigonometric functions. And also remember that the result of these theorems or the differential coefficients of the basic inverse trigonometric function, which are sine inverse x, cos inverse x, tan inverse x, etc., are very important, and it would be better for you to learn them by heart, as you will be making frequent use of these differential coefficients in solving advanced or complicated mathematical equations. So let's start with our first theorem on differentiation of inverse trigonometric function. And as per this theorem, or this theorem states, if x belongs to the interval -1 to 1, then the differentiation of sine inverse x with respect to x is 1 upon under root 1 minus x square. Or in other words, derivative of sine inverse x with respect to x is equal to 1 upon under root 1 minus x square for all x which belongs to the open interval -1 to 1. And if you remember, for finding the differential coefficient of a function from first principle, if f of x is a function, then the derivative of f of x with respect to x is equal to limit h approaches 0 f of x plus h minus f of x divided by h. So now in this case, our function f of x is equal to sine inverse x. And what will be the value of f of x plus h? Now f of x plus h will be equal to sine inverse x plus h. So in this case, the derivative of f of x with respect to x will be equal to derivative of f of x with respect to x equal to limit h approaches 0 sine inverse x plus h minus sine inverse x whole divided by h. And if you remember, you have already learned in the chapter on inverse trigonometric functions that sine inverse x minus sine inverse y is equal to sine inverse x into under root 1 minus y square minus y into under root 1 minus x square. And now applying that property here, then in that case, this derivative will be equal to derivative of f of x with respect to x equal to limit h approaches 0 sine inverse x plus h into under root 1 minus x square minus x into under root 1 minus x plus h whole square divided by h. Now to solve this expression, what we can do, we can simplify it. And now to simplify it, the best method will be, we shall multiply both the numerator and the denominator by x plus h into square root of 1 minus x square plus x into square root of 1 minus x plus h whole square. So now this limit becomes limit h approaches 0 x plus h into square root of 1 minus x square minus x into 1 minus x plus h whole square divided by h into x plus h into 1 minus x square plus x into 1 minus x plus h whole square divided by x plus h into square root of 1 minus x square plus x into square root of 1 minus x plus h whole square. And if you look carefully at the numerator, then here you can see the numerator is in the form of a minus b into a plus b. And from the properties of algebraic function, you know it very well that a plus b into a minus b is equal to a square minus b square. So now this numerator can be also simplified as, so now this numerator becomes x plus h whole square into 1 minus x square minus x square into 1 minus x plus h whole square, and which is equal to x plus h whole square minus x square into x plus h whole squared minus x square plus x square into x plus h whole squared. And now cancelling out x plus h whole square into x square, now this numerator becomes x plus h whole squared minus x square. And now this derivative becomes derivative of f of x with respect to dx is equal to limit h approaches 0 x plus h square minus x square divided by h into 1 upon x plus h into square root of 1 minus x square plus x into square root of 1 minus x plus h whole squared. And x plus h whole squared minus x square can be simplified as x square plus h square plus 2xs plus 2xh minus x square, and which is equal to 2x plus h. And now this finally becomes limit h approaches 0, 2x plus h into 1 upon x plus h into square root of 1 minus x square plus x into square root of 1 minus x plus h whole squared. And now the first expression becomes 2x when h approaches 0, 2x plus h equals to 2x plus 0 or 2x. And the second expression will be equal to, now when h approaches 0, then x plus h will be equal to x. And similarly, square root of 1 minus x plus h whole squared will be equal to x into 1 minus x square. So the right hand expression now becomes 1 upon x into square root of 1 minus x square plus x into 1 minus x square, and which is equal to 2 into x into square root of 1 minus x square. So now this whole expression reduces to 2x divided by 2x into square root of 1 minus x square. Now cancelling 2x from numerator and denominator, we have 1 upon under root 1 minus x square. So that means the derivative of f of x with respect to dx is equal to 1 upon square root of 1 minus x square. Or in other words, the derivative of sine inverse x is equal to 1 upon square root of 1 minus x square, where x lies in the interval -1 to 1.